check, 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 check. Can I get your attention, please? Thank you. So thank you all for joining us again for another installment of Achievers Tech Talks. We're very excited about this month's talk. But before we get started, just want to go over a couple of housekeeping items. So, as always, I just want to talk about our MeetUp group. Last time I stood up here talking about how big our group was, we were 540 people, and over the last month, we've been able to grow to 624 members. So thank you very much for all of you for your support over the last year. It's been a great journey. And as always, everything, all the resources will always be posted to our MeetUp page on meetup.com/achieverstech, and because MeetUp doesn't support video uploads, we host all of our videos on achievers.com/tech. So we'll send a note out as soon as we post it. So if you know anybody that missed the talk, feel free to share it with them. So without further ado, I want to pass the mic on to our senior software architect, Kaelen Proctor, who's doing his debut performance at Achievers Tech Talk. So give it up for him, guys.
Hi. As Zach said, this is my first tech talk, so I am a tad nervous, but I will power through. And there's going to be a lot of great content about profiling web applications, so sit back and enjoy the ride. So just to start off a little to describe myself, I would describe myself as a pretty typical back-end developer. And since joining Achievers about 3 years ago, I've worked on some of the biggest infrastructure changes, from implementing a cross-currency solution to helping get our database logically sharded. And I've kind of become the unofficial guardian of performance at Achievers. So let's just dive into profiling your web application. So no one is going to remember when your application is running fast, but they will never forget when it's running slow. The speed of your application directly relates to your business goals, as evidenced by these couple of examples. So Amazon saw that if their load times increased by 100 milliseconds, which is fairly a very short amount of time, it would cause a 1% drop in sales, which is millions of dollars in revenue to them. So not only is performance and how fast your application is important, but the scalability and availability of your application is even more critical, as every hour your site is down, the more business you lose, and you lose customer confidence as well. So to ensure that your application is performing and scaling well, you have to profile it to understand what it is doing. So I borrowed these definitions kind of from Expedia. They sound fancy, but when you break it down, profiling is basically just understanding how your program is executing. And for web applications, we're mostly concerned about how fast it is executing versus other facets like how much memory it's consuming. And as a profiling tool runs, you'll either end up generating a statistical summary of what it observed, which would be called a profile, or a stream of events that occurred, which would be known as a trace. And we'll see tools that do both as we go through. So before to talk about actually any tools, I just want to talk a little about the goals. So I want you to be able to walk away from this talk, download the tools that I mentioned, and try them out. Dig into how your code is running and see how you're performing. As well as I want you to become advocates for integrating profiling into your development culture so that performance is always at the top of mind. And I've seen when it's not at top of mind, it ends up just slowly degrading over time. And if you have seen some of the tools in this presentation, which I'm sure people will, that's great. It probably just means you're ahead of the curve. So it's a little agenda slide. So we're going to end up talking about what it is to profile a single request in your web application. We'll talk a little about how to find queries that are bottlenecking your database, a little on understanding exactly what your PHP code is doing, talking a little bit about how to profile and improve performance in your browser, and then we're going to talk more about doing that at scale. So using load testing to understand how your application scales to hundreds of users, and then production monitoring to make sure that as your application runs, that you're maintaining performance based on real user data. And after each section, I'll kind of stop for questions just to make sure that nothing gets lost. So before and more we embark on any tools, I just want to talk a little bit about goals and establishing baselines. So before you can set a goal on how fast your application can go, you need to be realistic and understand where your performance is right now. So I've got a question for the audience. Can anyone guess what the user's expectations of how fast your site can load is today?
Max 3 seconds.
Pretty close. The actual is 2 seconds, which is really damn fast, to be honest. And what that does mean is that your server has to be able to respond and send the response within about 400 milliseconds to give the browser all the time to render and fully load the content. So at Achievers, we're actually doing pretty well on the server side. Our application server responds in about 250 milliseconds on average, but our final load times are closer to 3 seconds. So we have more work we can do on our browser with profiling and improving performance. But in the end, and we've had this issue here, it's hard to balance improving performance and working on new things. It doesn't really matter if you have the fastest site if you have none of the features your competitors do. You may end up just falling behind just because of that. So a few notes before we get into more tools. Sorry, there's a lot of notes. I've tried to make the contents of this tech talk applicable to any language and framework, but as we are a LAMP stack here at Achiever, some of the tools are more geared towards MySQL and PHP. In the slide notes, I've put links to similar tools for other languages or frameworks where I found them. And now we're going to dive into actually profiling. So profiling for WebGrind is really just answering the question, why the hell is this page taking so long to load? From our expectations, we know we need to be able to send a response in 400 milliseconds or less. And if we're not at that level, we need to know what the issue is, whether it's our query that's taking too long, we have an API call that's taking too long, or maybe our application code is just doing extra work that we can eliminate. So the first thing we're going to do is look at the profiler that comes with the Coordinator framework, which is what we use at Achievers, which is a very simple, easy to use PHP framework. And it's very helpful at finding and giving you a good overview of what's going on in your application. So we're going to switch over to my other machine, and we're going to look at this with our demo application, Special K's Video Rentals, the latest in online video rentals. So this is what the page looks like, and if I scroll down, I put a little red border between, and everything below it is what the profiler in Coordinator gives you by default. When it's on, all it does is print out at the bottom, inject into your body, all this profiling data, including benchmarks, any get and post data, the actual controller that was called, and then what I would consider the most important part, the queries that ran. So we can see exactly every single query that executed and the time. I've kind of hacked the thing to add the total time at the top because I find it very useful. So if we scroll back up the top, we're going to look a little more into depth at this new feature of the site, the 6 degrees of separation calculator, for those who remember the early 90s movie. So this is an example of the 6 degrees where it's separated by 1 degree. Scroll down, 17 queries ran, all pretty good. I'm going to look at one more example, which is a little different. So this is, again, 6 degrees separation calculator, where this time it's 3 degrees of separation. But now the page takes almost 8 seconds to load. And if we scroll down, the number of queries is a little, let's say, inefficient. I actually contrived this example by creating an extremely inefficient breadth first search. So you'll probably not run into this example. We did happen to have one example in our production systems where we did get to 1,500 queries. So it's not completely out of the, well, maybe not out of the ordinary, but it's not completely out of the realm of possibility. So we're going to switch back. Hope this all works. So that's what the Coordinator profiler looks like. To enable it is pretty simple. Just add that line anywhere before the controller ends, and you'll get the content. And that's what it looks like. We just saw it. So how does this help? It's basically just an overall health check on what's going on in your request. And you can really easily see, as we saw, if there are slow queries, if there are a lot of queries being run, or if we have benchmarks that are taking, or that mean a piece of code is taking long to run. So as I said, the most important part is that database section, because in general, I would say your database is going to be your bottleneck in almost every web application. So it's probably the first place I look at when I do this kind of profiling on my own machine. But in the end, it's really just a guideline. If the request doesn't work well on your dev machine, in this case my laptop, it's probably not going to work great in production. If it does work on your machine, that doesn't guarantee it's going to work well in production either. And that's why we'll end up talking about load testing later on. And now just a quick poll to the audience. How many people, when they develop, are using tools like this, anything similar, any kind of profiling tool as they develop? Achievers' hands don't count.
Most this is like Chrome's development tool.
Yeah, that's exactly what you would. Chrome's developer tools are exactly what you would use to profile in your browser, though there are a couple other options that we'll end up getting into. So I found personally at Achievers that people weren't paying attention. They weren't profiling the code. They didn't take performance seriously. And so I wrote a lot of documentation on how to use profiling tools, which kind of became the basis for this tech talk. I shared it with everyone, and still no one was really paying attention. So as I said, I'm kind of the guardian of performance. So after another night of fixing performance issues the night before the release to make sure they didn't take our production systems down, I kind of got a bit tired of it and decided to create a solution, a profiling solution that no developer at Achievers could ignore. And that's the Achievers Performance Header. And basically, it's just, I leveraged the coordinator profiling data, but then put it at the top of the page and also tied it to our performance targets around the total amount of DB time we spend in a page, number of requests, and whether there are duplicate queries, because there should be really no reason to ever have duplicate queries in your web requests. I also then, the text color codes from green to red to give a really simple view of how close we are to our targets. And you would think with this right at the top of the page, color coded, tell you exactly what's going on, that people would pay attention. But they didn't. So we made one simple change. The leadership team at Achievers decided to make one simple change, and that was to force make the header open into its open state by default if it's far enough away from our performance targets. And it looks a little like this. You can't tell here, but the border actually blinks using CSS3 animations just to make it as annoying as possible. And so now, as you can see, it takes up basically the entire page. It's impossible to miss. If you're working on your machine, you can see when this appears on anyone else's machine. So it's really helped kind of make developers care about the performance and feel that, take pride in making sure that they don't see this. Yes?
You could also tie it to their bonuses.
That is a good question. Eris, how are we on that? Excellent. So we actually also, we did kind of talk about how we can integrate this with our culture, and what we did was get our QA department involved and have them start logging these kind of performance issues when they see this header at the same level as functional issues. So no dev can escape performance because they'll have to make sure it's fixed before it goes to production, or we're not going to code it in the release. And yes, hours were spent on making this as ugly as possible. So I believe when you're developing, you should always be profiling your code. It's just the sooner that you know and you see a change that decreases performance, the easier it is to fix. You don't have to look back 3 months ago to find a change that you made that now with new code is causing an issue. But of course, there's a time and place for optimization. And as the Dijkstra quote says, that's kind of after you've got something working. So once you've got a functional unit of code, that's when you want to start making it actually work fast. You don't want to stop. You don't want to do it before it can actually do anything. So that's a little bit about profiling. Does anyone have any questions for me? Yes?
When you switched it over to QA, it made it an important part of the overall inherent functionality. What proportion of profiling failures versus functionality failures did you start to see? Was it about 50-50?
So the question was, when we started getting QA to log these issues, these performance issues, what ratio were they with functional issues? So it's hard to tell. The way the way we started doing this was had one master Jira for performance, and everyone started commenting on it for all the different performance issues, and then I was basically just knocking off the comments one by one. So it's hard, and when we did that, we can't really pull the numbers for that, but I would say it wasn't that much, like maybe 10% were performance issues. And in the end, a lot of them came down to because if there was something that poorly performed that we needed on every single request, like on our left sidebar, then if that's performing poorly, it's just going to get logged a lot of times for every single page. Any other questions? Yes?
What do you do about having a data set in development that is useful for reproducing production, so the performance issues only got in production?
So,
Yes, you could, but unless you've got a representative database that we're working against, then you probably won't find very much.
So that is a point, and I was going to make it later, and you stole my thunder a bit. But yeah, so the question is, when you're working in your development environment, you're not really testing on your full production data, so you're not having a representative test. And basically, there's no real way to get around it other than actually testing on actual environments, like a staging or a preview environment. So really, in the end, profiling just comes down to being a guideline, as I said. You can't guarantee that it's going to perform well in production until you start doing things like load testing later on with a full environment setup.
So does that mean that the majority of your order screens and dev happen more in QA and staging and not as much in regular development environment?
Not exactly. I would say our database is denormalized, well constructed now, so it's difficult for something to be created, to be written on, that's going to work great on a developer's laptop, but not going to work great on our QA or test environments. But it is always an issue, and it's hard to solve. Anything else? We'll move on, and we're going to talk a little bit about databases. So as I mentioned, queries executed is probably the most important part of a web request because it's usually your bottleneck. So let's go and see about how to actually find those issues. And I don't think anyone can disagree with the slide where I say database performance is critical. It's just like saying chocolate is the most delicious thing in the world. There's no argument there. And this is doubly important because your database is a shared resource. So slow queries in one part of your application can affect queries in another part of your application, even if they're completely unrelated. And then the other thing being that it's not a simple architectural infrastructure change to start scaling your database and use master-slave configurations or create a DB cluster. So making sure your database is fast, critically important, which is why I just said it 4 times. So this slide is a bit glib. Really, you don't want to ever do option 1 or 2 because that's a lot of manual work. Option 3, where we're letting MySQL do everything for us using its slow query log, is the way we're going to go to find the queries that are bottlenecking our application. So if for those that don't know, the MySQL slow query log is functionality it gives where you can, if you turn it on, it will log any query that takes longer than a certain threshold of seconds to execute, and it will contain information on how long it took, the number of rows it read, examined, if it had any lock time. To enable it is pretty simple. You add the one directive, you set your threshold time, so in this case, it's going to log any query that takes more than 1/10 of a second to execute. And what does it look like? So this is an example I took actually from our production systems, and I obfuscated some of the table names to be secure. And actually, in production, we run a fork of MySQL, a drop-in replacement called Percona Server. So it actually gives a lot of extra information on the I/O times, whether they're temp tables, file I/O, and other things. Which is great because the more information you have, the better. Now, I can tell you from experience, trying to read through 100 megabytes of a log that looks like this to find a query that ran in a certain time frame is not easy. It's pretty darn annoying. So we're going to look at a tool that helps synthesize this log into a more readable and understandable format. And the tool is called PT Query Digest. It's part of the Percona toolkit, which has a set of scripts that are very helpful for many things. And what the PT query digest does is read your slow query log, aggregate queries, grouping them by their structure, so ignoring the exact parameters that are in the query, and then summarizes that data into high-level statistics that are really easy to understand. So we're going to take, just to quickly go, to run the tool is it's a Perl script, so all you need to do is execute it, point it to the slow query log, and point the output somewhere. The tool has many options, including specifying date ranges. You can write Perl things to filter what queries you want, and you can actually set it up to write these data to a database so that you can actually aggregate multiple executions of these digests so you can see how your application scales going forward. So let's take a little look at what a digest looks like. So this is the format I took from my developer laptop for the Special K video rental site, and we're going to dive in. So there's three kind of main sections to look at, and we're going to start at the top. So this is just overall statistics about what it read from the slow query log. So we've got the total number of queries that it read, the number of unique queries, the date range of those queries, and then statistics on the execution time, rows read, rows sent, etc. Pretty interesting, but pretty interesting. And the next section, which is by far the most important in this digest, is this section, which gives you a ranked set of queries from the most expensive to the least expensive. So we can see the first one, which it gives a query ID, which you can use to look up the specific statistics later on. We can see in total, it used almost 16.6 seconds for all the executions of the query in the file, and that was 78% of all the slow queries in the application. So moving on, after this section, it will print more detailed statistics for each of these ranked queries it ranked. So we're going to dive into the first one. And again, we see a very similar set of statistics, but this is just for this query. And it also gives an example of the query that it took from the slow query logs. I also omitted a few other things, like some nice histograms, just for clarity's sake. So what do we do now? Well, that second section, that ranked set, gives you exactly what you should start looking at. The most important things where you're going to get the most benefit out of making your queries faster. So basically, you look at the top of the list, you pop off the query, and you start digging into why it's not running quickly. And to do that in MySQL, to figure out why a query isn't performing, you have to run the explain command, which tells you the execution path MySQL is going to take to give you back that data. How to use and understand MySQL Explain is a tech talk in itself, and thankfully Dr. Aris Zakanthinos did a tech talk on this last year, so I suggest you go to the Achievers Tech page, watch the video, and read his slides, as they're very thorough, and he'll explain, exactly how to understand what the MySQL Explain is telling you. And as mentioned, run Explain on your biggest data sets, because MySQL can change its execution path based upon the relative sizes of the tables in the query. So it is possible, what that means, it is possible for a query that you've optimized to hit a tipping point as your tables grow and all of a sudden start executing in a different fashion than you expected, which has happened to us at Achievers. And that's why it's important to always keep up to date on what's going on in the slow query log. Optimizing queries once doesn't guarantee that they're going to stay performant in the long run. It's a good, you can be very confident they will, but it doesn't guarantee. So to get ahead, when it comes to MySQL and queries, to get ahead in performance, basically developers need to understand how to find those slow queries, which is using the slow query logs and the digest tool, as well as understanding how to run, explain, and actually figure out how to improve the performance of the queries. One thing we started recently at Achievers, thanks to Alex, who hopefully is in the back somewhere, is running the PT query digest once a week to see, and the email is sent out to all the developers, so we can have visibility into how our database is performing week to week. And if any query starts bottlenecking us, we get to know it pretty quickly. So that's a little bit about how to profile your database. Does anyone have any questions before we move on? Nope. Let's go talk about application code. So I have a theoretical question. Can anyone tell me what could be happening if you have your application server is taking a really long time to send the response to the browser, but all your queries are running fast, and none of your benchmarks are slow, and let's assume no issues with third-party systems? Any guesses? No?
What would be the problem?
Yeah, what could be a problem?
Function call?
Yeah, exactly. Function calls. It could just be that you have a lot of small pieces of code that are executing so many times that it just adds up. For example, that I thought of would be you have a recursive function that doesn't hit an end condition properly and is therefore doing a lot more work than you might expect. So I would call this the devil in the details, and thankfully there's a great tool called Colegrained which actually comes to a rescue in these situations. Because what it does, it's a command line tool that profiles all the function calls in your application and how long each of them takes. And it generates a call stack with all those timings. And what does it look like? The output looks similar like this, so not particularly readable. The good thing is that there's a lot of tools, or a few tools that we can use that can aggregate this data in a really easy to understand fashion. But before we go into that, running command line tools is not particularly webby, so is there an easier way to generate these files? And thankfully, yes. So Xdebug, which is a PHP extension for interactive debugging, actually comes with a profiling functionality that can generate these Colegrained files. And it's pretty easy to use. You need to just have the Xdebug extension enabled, turn the profiler on, set an output directory, and then it will start generating these Colegrained files every time you hit your application. The downside being that it's going to slow down your request by about 3 to 5 times, because it just takes that time to gather all the data, so obviously don't run this in production. Not a good idea. So we're going to switch over, and we're going to actually take a look at a tool called WebGrind. And what WebGrind does is aggregate the data into a more understandable format. So we're going to switch over. So just for context, this is the page that I've ground, would be the terminology. It's just a simple list of films. And we're going to open up WebGrind. So the UI, pretty slick. This one is not particularly interesting, so we're going to look at another. But I do want to say the baseline in this case, our baseline request is that this page takes 300 milliseconds to respond. So it takes 300 milliseconds for our application server to finish executing. So at Achievers, we are very concerned about web security, and we use the Open Web Application Security Project, or OWASP's, Enterprise Security API for input and output encoding, which is necessary for preventing cross-site scripting attacks. And if you want to learn more about web application security, you can watch the tech talk Matt York did on web application security, which is very thorough and informative. So I included that same OWASP library into my my test application and constructed an output encoded version of that same films list here. And I'm going to open up the Colegrained for that. So the first thing you might notice is it takes now 8 seconds to load the page. So we've decreased our performance by about 20 times, which is not good, I would say. So let's kind of look in the WebGrind UI to see what it's telling us. So the first thing at the top right, it's got the file that I'm selected, and we're looking at all these numbers in milliseconds. Then it gives a distribution of the function calls in the request, breakdown by whether they're internal PHP functions, includes, class methods, procedural. We get a total number of unique function calls and the total time. And then the meat of the WebGrind is kind of this list of functions. So for each function that happened in the request, we see the total number of invocation counts, which is in the tens of thousands, which is not great. The total self and inclusive cost. The difference between these two, the total self cost is the total inclusive cost if you subtract the cost of all the functions that this function calls. So just what's happening in that function. So we can also open up any of these and see all the different functions it calls and all the different places that call it. And then we can also link to source code through these nice little buttons. So as you can see here, we have WebGrind orders by default by total self-cost descending. So it pretty much similarly to the PT Query Digest, your first place you want to look, and when it comes to figuring out how you can improve the performance, is right at the top of the list. So this detect encoding function takes 3 seconds in total, or which is about 40% of this page. So switch back. That's what WebGrind looks like. Da, 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 da. So there are a couple other ways to visualize these grind files. Kcache grind, WinCache grind. They're all basically the same. Kcache grind was the original. And all they do, or altogether, they all aggregate the function calls, how many times they're called, how much cost they did. So WebGrind I like, though, because it's really simple, easy to install, and I actually prefer the format of the output it gives you. You can't see the full call stack, but you get a really nice summary. Installation is also pretty simple. Just download the zip, set up an Apache, and go. So back to our example. Are we screwed, and are we stuck with having a security library that decreases performance by 20 times? Well, obviously not, or this wouldn't be a very good demo. So when we started securing our code and we included this library, we weren't really paying that much attention to performance. And that's why we were kind of caught with our pants down when it came to release time, when we started actually looking at why our pages were being so slow. So let's switch back, and we're going to look at one more grind file, or WebGrind. And this is the same output encoded pages, but it's using a Achiever's optimized version of the OWASP library that we use internally. And as you can see, the time is not nearly as disastrous. It's still twice as long as our baseline, but that's pretty much because output encoding is always going to be an expensive task. But no longer, we don't have method calls in the tens of thousands, and while it is slower, it's still reasonable at the very least. So keep that in mind when we switch back here. Again, as I said, output encoding is not a simple task. The way the OWASP library works is that basically every non-alphanumeric character is encoded to a Unicode code point based upon the context, and it makes no assumptions on the incoming data. It's a very generic library, so it has to do a lot of encoding detection and normalization before it does any actual real work. But we were able to find optimizations. So how did we do it? As I said, we kind of got caught with our pants down when we started looking into this, and we weren't really sure why our pages were taking so long to load. The queries were good, nothing specific in our application was slow. And the first thing we did was download WebGrind. And we actually were able to, we started using the tool and digging into what actually was going on in our PHP code. And as you might guess from that, the WebGrind we showed, we started digging into those method calls that were being called tens of thousands times per page. And that's where we got a good start into where to look into the OS code to figure out how to make improvements. And then, I'm not going to lie, it took few achievers several days to actually dig in, figure out what the OS code is doing, and figure out how we can improve it. So it wasn't a simple task. And as you know, we do these tech talks as a little bit to give back to the community. So we're actually going to make our optimizations to the OWASP library available on our Achievers GitHub page. So look out for that. We're going to make a few modifications and write a little bit of documentation, because I know people would like to actually understand the changes we made. But in the end, the changes we made were fairly significant and required a very thorough understanding of their code. Thankfully, with PHP, we can do a very simple thing to improve the performance of our code without making a single change to a single line. And that's opcode caching. So as you might be aware, PHP is an interpreted language, so every request, the file has to be read from disk, parsed, compiled into opcode, and then finally executed. What an opcode cache does is allow you to skip those first 3 steps by caching the compiled opcode in memory at the expense of a little bit of RAM. The performance boost is pretty impressive. You can get between 2 and 5 times. And it's really easy. Then you got options in APC XCache Send Optimizer. We use APC, and it's slated to be included in PHP 6, bundled into the core. Setting up APC is pretty simple. You get the download and install the extension or compiler yourself, and basically turn it on and enjoy the performance boost. The only things you might want to think about when it comes to the options are how much shared memory size you're going to give it in megabytes, and then whether it should check if the PHP file has been modified every request or not. Because if it doesn't check, then it won't ever, if you make modifications, it won't pick those modifications up. So again, you've always got to be profiling your code. WebGrind is not going to solve all your problems, and especially it's not going to solve your problems if you're not using it. So it's very important to make sure that as you're developing, you run WebGrind and you look at what your PHP code is doing to see if there are any functions that are bottlenecking your code. And I find for me, it's become pretty easy for it to become just second nature for me to profile with WebGrind every day or 2. But on the other hand, for a really quick boost, just start using an opcode cache and never look back. Any questions on PHP?
Where's this cache?
Cache?
Where's the cache? Those function calls are all going to be cached. You said they're going to be cached. That's what this is.
So an opcode cache will cache the compiled executable or not executable, but the compiled commands for your PHP file.
Right.
So if you modify the file, it will have to regenerate. It will regenerate that file unless you have APC set so that it doesn't check if the file is modified. So it does cost you some memory to keep all those opcode caches, but the performance boost is way more than worth it, especially how cheap memory is these days. Yes?
So the OWASP
Security library?
yeah, the fixes, the improvements that you've made.
Yep.
Have you sent it back to the OWASP project?
So we have not. So the PHP version of the OWASP library is actually not technically production ready. So the OWASP, their base version is a Java library, and the PHP version isn't even on their latest Java library, so it's not really actively maintained. So we do want to give those changes back, but just in case, we're going to make them available on our own GitHub page in case they don't ever respond to us or anything like that. Anything else? Okay, let's move on. So at this point, we've talked about kind of general request profiling, your database, like figuring out what's going on in your database and in your application code. So we've kind of covered the main aspects of your application server sending out the response. So now it's in the browser. How do we know how our browser is performing, and what can we do to profile it and improve its performance? So thankfully, in this case, browser profiling, there's a wealth of information online about it. There's by far the most articles written on how to profile and improve the performance of your browser compared to your database or your application code. So I doubt anyone will be surprised by the tools I talk about. But before we go into those, let's talk a little about kind of the developer tools that we can use. So I'm sure most people, anyone who's worked on the front end, has used Firebug or some of the native developer tools that come with Chrome or Safari. And these literally are the basis of profiling in the browser. So the most critical aspect of performance in your browser is how fast it can request, download, and use resources. A resource that takes a while to download or execute will directly affect how quickly your content can be rendered, styled, and usable. So when you use a developer tool like this, the most important tab, in my mind, when it comes to performance, is the network or timeline tabs, because you can see a timeline of exactly all the requests being loaded, how long they take, whether they're blocking, and then you get to also see when your content is fully loaded and the final load event is fired, which means that your page is basically ready to be used. But how do we actually make use of this information? So the good thing is someone else has already done the work for us. So Yahoo's YSlow and Google's PageSpeed are both browsers extensions that are the kind of the industry standard for profiling browser performance. And what they do is they analyze your page, your request, score it based upon a variety of rules, and then give you recommendations on what you can do to improve the performance. And I'm not going to say it's simple to actually implement those recommendations, but if you follow their advice, you'll get the biggest bang for your buck. So we're going to look a little bit. I'm not going to actually show them on here because it's just so simple. This is an example of YSlow. We can see it gives us an overall grade, not a great one. And it breaks down for all the rules it tested you on. It gives you an individual score, and it gives you some information on how to improve why the rule is important and what you can do to improve it. So here I need expired headers, but I'm running this on my local machine, and I really don't care. And next, we have Google's PageSpeed. Very similar. We get an overall score. I got 0, which is not great. But on the other hand, compared to YSlow, it organizes its recommendations from the largest potential wins, so highest priority, down to the smallest. So this is kind of, I'm going to skip over these two slides pretty quickly, but basically this is summarizing kind of all the things you can do when it comes to browser performance to make things better. And again, implementing any of these suggestions is not trivial in most cases. So instead of really going into depth on how to implement or how to solve these things, I want to show off another kind of cool profiling tool in the browser, and it's another tool from Google called Speed Tracer. And it's a Chrome extension that shows a timeline of the internals and it records UI events as they occur in your page, and kind of gives you a timeline of how sluggish, in terms of resource constrained, the UI thread is. It's pretty cool. I find it interesting, but any of the issues you might find with it are so much lower priority than what YSlow or PageSpeed would tell you, unless you have, let's say, an extremely script-heavy web application. So I'm just going to quickly switch over, and we're going to just take a look at Speed Tracer itself. Here's an example of PageSpeed. Same sort of thing. So this is Speed Tracer. I don't know why I'm not using my mouse. And this is taken from my, again, the Special K rental site. And at the top here, we have a sluggishness graph. So right up the line up here, which may be hard to see, is basically 100% of your resources are being consumed. So you want your peaks to be down near the bottom. Otherwise, it means if something hits 100%, other things are blocked, waiting for resources to be freed up. Below that, there's a network timeline, which just allows you to kind of cross-reference network activity to sluggishness. And then near the bottom is kind of the timeline. Anyone who's seen like Firebug or any developer tool, it looks familiar. It's a timeline of what's happening, including things like style recalculation, parsing HTML, and we can also click into any of these to give more information. So it's kind of cool, but the information you get is is not as useful to improving the performance of your browser as what YSlow or PageSpeed would tell you. Switch back, and that's what it is. Past that. Just to make it simple, use YSlow, use Google PageSpeed, implement their recommendations, and you're going to get the biggest bang for your buck improvements in your browser performance. Again, not that they're actually simple to implement the recommendations. Sometimes it's difficult. Any questions on profiling in your browser? No? Let's move on. So all the things we've talked about so far, from profiling PHP to your database to even your browser, have all kind of been in the context of one developer testing on their machine. So we don't really know at this point whether a code is going to scale to hundreds of users concurrently accessing it. And to answer that question of whether it will scale, we're going to talk about load testing and stressing the heck out of your code to make sure it runs well. So load testing has a few things that are really great in that it helps you locate issues of scale where if you start, more people start hitting your site, if let's say a piece of your infrastructure, maybe your database, starts not being able to deal with all the requests and starts bottlenecking your whole application. And also, if you load test with a user load that's close to what you expect in production, you get much more accurate results on average response times, which gives you more confidence that your application will actually perform well before you push it to production. So before we kind of dive into exactly the tools you can use to load test, you kind of need to have a basic idea of the critical path through your application. So what pages do you want to load test to make sure that they scale and perform well as hundreds of people are accessing them? So at Achievers, our basic example is, for our test, is we log in, hit our newsfeed, then the catalog, do a user search, make a recognition, which actually saves data to the DB, and then it logs out. So these contain pretty much the most commonly accessed URLs in our application. And it's really nice to have that recognition step that actually writes data to the database, because it guarantees that MySQL actually has to do work to respond to these requests. It's not just sitting there sending you back cached records. So there are many options when it comes to actually choosing a load tester. So there's command line tools, there's GUI tools. LoadImpact.com is actually a software as a service that you can run online. It's kind of cool. It looked really like hackery when I tested it out. But we're going to focus on JMeter because that's what I know. Surprise, surprise. So it is a part of the, it is owned by Apache, and it's a GUI written in Java for building test plans to hit a variety of endpoints, and that one of those endpoints is HTTP. And it has a lot of functionality, which makes it a little confusing to use off the bat, but it's, you're able to set up concurrent threads, you're able to assert on responses, and has lots of different ways on reporting on the data that's coming back from the requests. It does take a little time to get used to its UI and the peculiarities around it, but it's very powerful. So we're going to switch over and kind of look at what JMeter looks like. So this is the UI, and this is the test plan I created for, again, Special K's rental site. So up here, the first thing that's kind of the most important is the thread group. So here I have it set up so that 50 concurrent users are going to be running in this test. So I'm going to stress my server with 50 people at a time. There's some cookie managers and request defaults just to make life easier. And then the test flow we have is we're going to hit the site, log in, hit a few pages, and then it's going to log out. So one thing we should do just to make it easy is show how to actually add a new request. So we're going to add, we're going to go, oh, no, I got to do it from here. Add under sampler, which always confuses me, we're going to add HTTP request. And we're going to name it admin. We're going to make the path to hit /admin as it's relative to the request default. And then I'm going to move it before we log out, because doing it after we log out is not a good idea. So that's kind of how you can set up a test plan, and I'm not going to run it because I don't want my laptop to die, but I will show you an aggregate report that I did from before this application. So we can see each URL was hit 50 times. We have all these numbers on the average, the minimum, the maximum response time, if there are any errors, throughput, and then total kilobytes per second. So what we can see here that's interesting is that our minimum number is very different than our average number. And that's not particularly surprising given that I'm testing this on my laptop with 50 users and both trying to test and serve up the requests, which makes my laptop hit 100% CPU right away. Which again brings up the point that when you want to do this kind of testing, this load testing, you want to do it on infrastructure and environment as close to your production systems as possible to get the most accurate numbers as possible. Switch back. Again, JMeter GUI, skip through that. So the question now becomes, when should you load test? Question.
Yeah, sorry, just a quick question.
Mm-hmm.
When you are load testing against like a production-like environment, do you initiate the test on the server itself or from a local machine? You have traffic, the latency of traffic.
So it's probably a better idea to do it from a local machine than on the server, so that you're not stressing the environment on both the requests and the responses. And anyways, if you're going to try to simulate what a real user is going to end up seeing, you kind of want that network latency and time, because that's going to give you better or more accurate results to what a user might see. But in the end, you're kind of probably going to do this. Your local machine and your test servers are probably going to be close. Like our environment is in Brampton, so we're physically much closer than someone in California. So again, the numbers aren't going to be 100%. But you're kind of just looking for confidence that your response times aren't going to go through the roof as you add load to your servers.
Is 50 a regular number for you guys?
Matt, are you in the audience?
Yeah.
What do we do our performance on? 100? So that's actually, we could bump that up because our average number of concurrent users on Achievers is 300. So we're probably not getting the best numbers we can from this, but we have a few issues with our load testing anyways, because we don't do it very often.
It doesn't particularly matter the number though. It's more about you put on your test server what's in production, and you measure a baseline, then you push what you're going to be pushing to production, and you run the same test, and you look for large differences.
Yeah, so what Matt said, for those that didn't hear, is basically you want to test the baseline, so what's actually on your production servers, and then push what your new code that you want to push to production and see how it changes. So see the difference, the delta. So you don't actually need to have exactly as many users as you would normally see on your production systems. So when it comes to when you should load test, at Achievers we do 2-week sprints. So every 2 weeks, new code, new usable code should be added to our release candidate, which means that every 2 weeks we probably should be running these performance tests, because we can then see exactly, or as soon as possible, if something new is going to degrade performance. We don't do that consistently yet, and again, it's more important to be consistent about this, so you have a good trend line that you can see, because you don't want that trend line going up and your performance is decreasing. But if you can't figure out that trend line, that's even worse. If you have tons of data points here and tons of data points here 3 months later, you really can't get a good idea of what's going on. So it's important to be consistent. And if you do happen to have some sort of automated build or test suite, that's a perfect place to also be load testing. So when it comes to getting ahead, we've kind of learned how to create test plans with JMeter, and not a full demo, but I'm sure you can learn. So now we can run them and have a better idea of how our application will handle load, and be more confident that when we push it to production, we're not going to cause a catastrophic collapse. And another point down here, if you want, you could try testing with more users than you have on average. So for example, at Achievers, as I said, we have 300 users on average, but we've seen spikes up to 800 users from doing events and things. And I'm actually a little proud to say that we don't really see that much difference in our response time. So our application can actually scale very well, and we've worked really hard to get ourselves there. Any questions before I move on? Nope. OK. So now we've load tested. We have confidence that our application is going to scale. But do we actually know that's going to be true? There's something weird could happen, and we could have issues. So to really know that our application scales and has great performance, we need to actually monitor what's going on in production. And so there are a few different types of production monitoring tools. You've got your IT-centric tools like Zabbix, which really are more geared towards how your servers are doing, whether they're using memory, CPU, disk space. And there's sort of marketing-centric tools, like I'm sure everyone's heard of Google Analytics. But we're going to look at a suite of tools that basically are centered around profiling your application as it runs and letting you know if there are performance or scalability issues. The fancy name for this set of tools is Application Performance Management, or APM. And they basically combine profiling the guts of your application as it runs with diagnosing and flagging issues that might impact your performance or availability. The one I'm going to talk more in depth about, so there's a few options here. We're going to talk more in depth about New Relic as we run it here at Achievers. APM tools don't come cheap. There are a couple free versions. Both New Relic and AppDynamics do have free versions, free light versions that give you some features, but the full versions will likely cost you quite a pretty penny. So they're not, they may not be accessible to startups, but if you can get a full version. The amount of insight and raw data, real data they give about the performance and scalability of your application is more than worth the cost. So here are some of the benefits that you might get. You get real-time dashboards and user monitoring, so actually how their browser, how long it takes to do things, error reporting, other things. And the downsides is a much smaller list. Other than if we exclude the whole cost scenario, the only really downside is that you have a minuscule performance drop in the 1 to 2% range, which is more than worth the price to pay for the concrete, real data these tools will provide you. So what exactly is New Relic? It is a software as a service APM platform with a really slick web UI. The free version contains some of the basics, so real-time server monitoring, application response times, and user monitoring, but it only will retain this data for 24 hours, so you've got to actually act quickly on it. The Pro version, which we have at Achievers, which is $150 per server per month, so pricey, has all those features plus more, including full database traces, full web transaction traces, and a slew of extra features. And I would say, if I was to ever start a web application project on my own, I would make sure to use one of the free versions from the beginning, just because the data they provide you is so useful and real. So installation, not as simple as the other things we've talked about. So find your IT guru and follow the instructions. But basically, New Relic for PHP has two components. An extension, very similar to Xbug, that runs as your application is going, and then a daemon process kind of gets that data and transmits it to the cloud to the New Relic servers for aggregation and statistical analysis. The UI, as I said, is pretty slick. So this is the overview in New Relic, and you've got a chock load of auto-refreshing graphs. So you could set the time range that we're looking at. So we're looking at 3 hours here, and it's going to always get the latest data. And we actually run this dashboard on a TV in our development department, so at any moment of the day, someone can look at it and see whether or how our performance is. So let's dive in a little bit into the UI. So this is the web transactions page. So on the left side, we get the browser and the application server and browser load times, and right now it's sorted by the percentage of total page load time, which basically means that the most popular URLs at the top. So the things that are most accessed and therefore are the things you want to optimize the most. On the right, we get a bunch of graphs on response time and throughput, and hard to see down here, but it gives you some interesting traces you should look into, where interesting basically means slow. And if you were to click into one of the the transactions on the left side, it would bring up a new pane with statistics about that transaction itself. So how the response time has changed over time, throughput, and then more traces that you should look into, again, the slowest ones. If we click into one of those traces, we get the real data about what happened. So in this case, someone from Mississauga using Chrome 26 hit a page, and you can see the breakdown on times in how it is. So in this case, DOM loading took by far the most amount of time for this person. And you get to see, compared to your baseline how it is. So you can really easily see that this person had a bad experience. They were waiting 12 seconds for the page to load, which is 6 times worse than what we want to get to. There is also a very similar set of UI for database transactions, and this web transactions and the database together are what I would say are the most invaluable pages in New Relic, because they have helped us identify issues that we didn't catch in testing, because we are a very configurable SaaS platform at Achievers, so it's not possible to have 100% testing coverage. And having the real trace details to understand what's going on has been invaluable when it comes to solving customer issues. We're going to move on to some of the reports. So New Relic has several reports. This is the scalability report, which maps on the x-axis requests per minute and on the y-axis response time. So in general, you want that trend line to be as flat as possible, because that means as traffic increases, your response time doesn't change. So we're pretty good at Achievers. The difference, we basically go up by about 40 milliseconds in total from not having any traffic to having lots of traffic. And anyways, in general, those numbers are well below the 400 millisecond threshold, so we're doing pretty good. What you don't want to see is something like this, where your response time is basically increasing linearly with your traffic. I won't go into any more details into what New Relic gives you, just because there are so many features that we'd be here all night, and I've already used up too much of your time. But even the basic features that you would get in the free version, like the response time and end user monitoring, are so insightful that I actually can't imagine how we used to develop without having New Relic in-house. And since I've started to use New Relic, I've come to the conclusion that just like I wouldn't write an application without logging to be able to see what's going on in production, I wouldn't write a web application without an APM tool in place to have real actionable data on what's going on, as it really helps take away a lot of the guesswork when it comes to figuring out where your application is having issues. Does anyone have any questions on APM tools or production monitoring in general? No? Well, that's good. So we're getting close to the end of the presentation, so I just want to go into some final words and a recap. So when it comes to what we've learned so far, saw that profiling, so just general request profiling, is kind of an overall health check and what's going on in your application. Digesting your slow query logs to be able to really easily find the queries that are bottlenecking your application. Talked about grinding your code with WebGrind to find the weird hidden details where lots of PHP time is being spent. And then really just use YSlow and page speed to figure out why your browser responses are slow and what you can do to make them better. And when it comes to maintaining your performance, use JMeter or another tool to load test to make sure that your application can scale, and then monitor your production systems so you actually know that your system is scaling. And I would say when it comes to using these tools, just download them, try them out, get a feel for them, and once you kind of understand how they work, try to think about where you can start using them in your organization to make sure that performance is always at top of mind. And then in the end, pointing all together, I just want to reiterate some themes I've kind of touched on in this presentation. You got to integrate profiling and performance into your development culture. If people don't know how to profile or how to improve performance, they're not going to be able to do it. So you need to be able to teach developers how to use the tools and make sure they use them and people are held accountable. As well, it's great to have visibility in actually how your code is performing, which is what things like your New Relic give you, as well as the fact that we're, as I mentioned, we're sending out our query digest every week to developers. Profile, load test your code before you push it to production, so you can actually be confident that it's going to scale. And then run your monitoring tools in production, so you actually have real user-driven metrics and ideas of where you can improve performance. And really, never let up. If you stop caring about performance and profiling, it's going to catch up and you're going to fall behind and you're going to have to scramble to make things faster. Thank you, and if there's any questions, please give them. Yes?
What are your thoughts on XHProf?
XHProf? So what are my thoughts on XHProf? I have not used it. I was looking at potentially including it into this presentation, and I know there was a talk a couple days ago in the area about it, but I haven't used it, so I can't really comment on it. But any kind of profiling tool you use is good, to be quite honest. Anything else? If not, I'll hand it over to Zach.
Thank you very much. Awesome. Thank you, Kaelen. So just want to end off the talk by mentioning a couple of things. One, we are hiring all over our organization, so if you want to work with great developers like Kaelen or in other parts of our business, feel free to check out our careers page or reach out on any of the Achievers Tech groups, and we'd be more than happy to engage in a discussion with you about that stuff. And lastly, reach out to us. Our goal at Achievers Tech and Achievers Tech Talk specifically is to give back to the Toronto tech community and spark meaningful conversation. So if there's anything that you want to know about how we've built our application and how we maintain it, or anything else about our business in general, reach out on any of those networks. Kaelen has also assured me that he's going to answer any questions that people have about this talk specifically on any of the social networks, so you can reach out and engage with us there. And once again, all the slides and resources and videos will be up on the MeetUp page and the Achievers Tech page. So stick around for a bit. We'll be serving a few more drinks. Talk to anybody with a purple lanyard if you have any questions about Achievers, and we'll see you guys at the next talk. Thank you.
Thank you. It was awesome. Well,